This is a transformer, and this is a pretty big one, but it's so when we look at the transformer rating, so you get the first thing you'll see is some people think this is like a paper shredder, but definitely don't stick your fingers in here because this is like bad. But you'll see a sticker on here, so that's the first thing you'll see, transformer sticker, and it'll say, you'll see primary voltage. So your primary voltage is 600 volts coming in, and then your secondary voltage is 208Y/120. So this tells you how the transformer was wired, and there's two ways to wire one. You got so you can do Y or you can do delta, and that gives you a different voltage output when you have two wires, so a 2-pole breaker later on down the line. So you'll be careful of that. And then you go see, you got the model, and then this tells you the phases, so it's 3 phases. And then over here we can see like what it's rated for. So it's rated for 300 kilovolt amps. That's how much power you can do. So you gotta pick a transformer that's rated for the amperage that you want, otherwise you will melt the transformer. And then it tells you the hertz, the K factor, which is suitable for like certain types of location, and impedance, the class, the temperature rise, what you can use for connection, and then the weight. Now this one's in French though, so you can see like this is designed. It can take a temperature rise of up to 150 degrees. They do get very hot. Now, when you wire this thing up, you're going to see primary voltages and secondary voltages. So normally, your secondary is what's coming out. So now, some of these work two ways. So you can take 208 volts and turn it into 600 volts if you wanted to. But basically you can see if you set this up as a 3-phase system, then you get 208 volts across the three. So when you look here, the way these are wired, you got 3 phases that are out at different angles, because this is alternating current. So, and they're 120 degrees apart, so this is actually like a sine wave. And in the center you've got your neutral, which is x0, and your phases are x1, x2, and x3. So you can connect a single phase panel, for example, to x0 and x1, or x0 and x2, or x0 and x3, and you can get power that way from your neutral. But that can lead to trouble because your phases won't be balanced. Or you can connect a 3-phase panel to x1, 2, and 3, and you still have to use your x0 for your neutral to your panel. Now notice there's no neutral coming in. There's only a neutral going out. So the transformer is generating the neutral. Now, this thing, what you'll see is, so on the ends are H's. So there's H1, H2, and H3, which are the 3 phases coming in. But you'll notice there's numbers here because there's different jumpers. So what can happen is on your wire from your panel to your transformer, you could get the voltage starts to drop as the wire gets longer. So if your voltage, this thing's designed for 600, so if your voltage right at the transformer is 600, then you connect the jumpers inside to 3, 3, and 3, and then this will give us 600 to 208. But if our voltage has dropped, then what we do is we move our jumpers to 5, let's say, or 4. So this, if our voltage is approximately 585 volts or 570, then we can then we can do that. And if our voltage is a bit too high coming in, then we could use a tap like 1 or 2, and so then this transformer will account for the voltage difference in the output. Now it's not like a computer or anything. What happens is, the way this works, all this is really is a big coil of wires inside, and by tapping it, we're lengthening the coil or we're shortening the coil. And so what's happening is you got on one side a big coil and on the other side a small coil, and so as the power goes through one coil, it creates a magnetic field, and the magnetic field creates current in the other coil, which gives us our output. And the ratio of coil sizes changes the voltage. So if on this side I got 600 or wire wrapped around 600 times, and on this side I got a wire wrapped around 208 times, then I get my voltage difference. That makes sense. So now we do that for three phases, and that's how we end up with a transformer. But what we want to make sure of is that that this thing is tapped correctly. So now your voltage is never going to be perfect anywhere. You're allowed to have a 5% voltage drop between the source and the final amount. So if your voltage drops too much, then you just gotta use a thicker wire. If you have any questions, please post a comment. Thank you.